So we're going to talk about formation of monatomic ions in this section. And monatomic cations and anions are simply ions or cations and anions that are formed from a single element. Like I said, later on we're going to look at what these things called polyatomic ions. But for now we're going to stick with monatomic, made from a single element. Okay, so in the last section, we kind of saw an example of sodium and chlorine coming together and forming sodium ions and chlorine ions are actually called chloride ions. We'll talk about that here in a little bit. What we want to do is kind of be able to predict what the charge of the ions is going to be, because they're not all one or just positive or negative or 1 plus and 1 minus. There's actually some 2 pluses and 3 pluses and so on. So the first thing we'll talk about here is that the charge of an ion is the number of protons minus the number of electrons. So if there's more protons, it's going to be positively charged, and if there's more electrons, it's going to be negatively charged. Ultimately, what the formation of ions comes down to is valence electrons. Remember, valence electrons are the electrons in the outer energy level of the atom, and those are the ones that are actually going to interact with atoms that come near the atom we're talking about. Okay, those outer electrons, those ones that are farther from the nucleus, are going to be the ones that interact with atoms that come around. So we want to look at the number of valence electrons a system has, or an atom has. And if we look at sodium and its electron arrangement, we can see that sodium, which is an alkali metal, it's in the first column, has 1 valence electron. And it's sitting in that n equals 3 shell, or that n equals 3 level. And then when we make a sodium ion, it loses that electron, and I get the electron configuration, it's called, that looks like that. Where now we're back to just having this kind of full energy level with 8 electrons. That electron configuration looks exactly like neon's, and we know neon is not reactive at all. So there's something about that electron configuration that makes the system really stable. Okay, now there's a difference between sodium ions and neon atoms. Remember, while the electrons might be exactly the same, the nucleus is different. The number of protons in sodium is 9, I believe. Nope, it's 11. And the number of protons in neon is 10. So the atoms, or the identification of them is different because we identify atoms or ions to the number of protons, not the number of electrons. Okay, so a sodium ion and the neon atom have similar looking electrons. They have 10 electrons each, and those electrons are arranged in the atom exactly the same. Okay, so sodium is an alkali metal. It's in the first column, and all the alkali metals have 1 valence electron as atoms. So all of those are going to lose 1 electron to become ions. So all those elements, lithium, sodium, potassium, and so on, when they form ions, are all going to be that single plus ion. Now, if we go to the second column, the alkaline earth metals, the first one of those is magnesium, Mg. And if we look at the electrons in that, we can see now that there's 2 electrons in that n equals 3 energy level. So when magnesium becomes an ion, both those electrons leave, and I get a 2 plus charge, because in the magnesium atom has 12 protons, and I just lost 2 electrons, so the magnesium ion has 10 electrons, and 12 minus 2, or 12 minus 10 is 2, and we put a charge on it after the number. Okay, 2 plus. And you can see that's what we write in the upper right hand corner of magnesium. because it's more than one, we actually include the number, right? Because for sodium, we just had a 1 plus, but we just wrote plus and not the 1. That's just how we do it. So magnesium is going to be 2 plus, and all the alkaline earth metals are going to be 2 plus because they all have 2 valence electrons. So calcium would be a 2 plus, strontium would be a 2 plus, barium would be a 2 plus when those atoms form ions. Those are all the alkaline earth metals, the second column. Okay, so if we look at aluminum, aluminum on the periodic table is over in that 3A column. It's got 3 valence electrons, so it looks exactly like magnesium's electron configuration, except it's got one more dot in the N equals 3 energy level. So when aluminum becomes an ion, it loses those 3 valence electrons, and aluminum becomes a 3 plus ion because it's got 13 protons and only 10 electrons. If we go the other way and look at what's going on with the nonmetals, remember nonmetals are going to gain electrons. So if you look at fluorine, fluorine's in the halogens. The halogens are the column right next to the noble gases. So fluorine has 7 valence electrons. It's got 7 electrons in that N equals 2 energy level. So when it becomes an ion, it gains an electron. So it takes an electron from somewhere else. That's an electron. And it goes into the fluorine atom and makes it a fluorine ion, a fluoride ion. And we can see it's negatively charged there. Okay, it's because now fluorine has 9 protons. It added an electron, so it's got, minus 10 electrons. So now it's got more negatives than positives. So overall it's a 1 negative. But we don't write the 1 when we put it in the charge like that. Okay. Again, when fluorine converts to a fluoride ion, when it gains an electron, you can see that its configuration is the same as neon, which is a noble gas. Okay, it's not neon because it's got different number of protons, but the electrons are the same. So when we name anions, when we name monatomic anions, we're going to end them in IDE. So Cl minus, chlorine with a negative charge, the chlorine ion is going to be called the chloride ion. And you can see here, the fluorine atom, when it becomes an ion, is called the fluoride ion. So all our single element ions, or anions, are going to end in IDE. So when oxygen forms an ion, it's going to be called the oxide ion. When sulfur forms an ion, it's going to be called the sulfide ion. When bromium forms an ion, it's going to be called the bromide ion. Okay, ends in IDE. So anions of single elements end in IDE. So basically we saw metals are going to form cations. They're going to lose electrons. Nonmetals are going to form anions. They're going to gain electrons. So if we look at that on a chart, we can see the ions that are going to form. And we can predict that from the number of valence electrons. So the alkali metals, the atoms have 1 valence electron. All of them lose that 1 valence electron to become ions. The alkaline earth metals all have 2 valence electrons. So when they become ions, they lose both those valence electrons. Aluminum has 3 valence electrons, so when it becomes an ion, it loses the 3 valence electrons and it becomes an ion, aluminum 3+. Okay, and if we're going the other way, the halogens, they're going to gain 1 electron to become negatively charged. Oxygen and sulfur, which are 2 away from the noble gas, are going to gain 2 electrons because they have 6 valence electrons. They're going to get 8 total. So they're going to have -2 charges. Nitrogen and phosphorus, when they become negatively charged ions, anions, they're going to gain 3 electrons and have 3 more electrons than protons. So it'll be 3 negative or negative 3 ions. Okay, but the last thing to note is that some of these elements, the metals, the transition metals and a few over here, a lot of times have more than one stable ion. Okay, the alkali metals, alkaline earth metals, and aluminum, they have one ion. The alkali metals are all 1 plus, the alkaline earth metals are all 2 plus, and aluminum is 3 plus. But these ones in here, they can have more than one ion. And while it's not that big of a deal, we're going to have to deal with that when we name them. Okay. That's the end of this section, and I will see you in the next one.